Hello students, welcome to our YouTube channel Experience Tutor. Our website is experiencetutor.com. Today we will discuss NCERT Solution for Physics for class 11th, chapter 2, Units and Measurements, part 9. Here is our welcome message. Before we begin today's class, we request you all to subscribe, like and share our channel. Please click on the subscribe button to support us, and also click on the bell icon to get automatic notification whenever a new video is uploaded by us. Let us start our lesson. So today we'll do question number 2.29. So let us check what is the question. So 2.29, the question is, a laser is a source of very intense monochromatic and unidirectional beam of light. These properties of a laser light can be exploited to measure long distance. The distance of the moon from Earth has been already determined very precisely, being used a laser as a source of light. The laser light beam at moon takes 2.56 seconds to return after reflection at the moon's surface. How much is the radius of the lunar orbit around the Earth? So time taken question number 2.29, time taken by the laser beam to return to Earth after reflection from moon is equal to 2.56 seconds, which is given. Speed of light is equal to 3 into 10 to the power 8 meter per second. Time taken by the laser beam to reach moon is equal to half 2.56 is equal to 1.28 seconds. Why we have done half? Because the time given is to go and to come, to go to moon, and the distance covered by the laser from earth to moon again back to the earth. So we have divided by 2 to get how much time it takes to travel one way. Radius of the lunar orbit. Distance between the earth and the moon is equal to 1.28 multiplied by 3 multiplied by 10 to the power 8 is equal to 3.84 multiplied by 10 to the power 8 meter. That is 3.84 multiplied by 10 to the power 5 kilometer. So this is the distance of the radius of the lunar orbit. Now let us see the next one. Question number 2.30, a sonar, sound navigation and ranging used ultrasonic waves to detect and locate the object underwater. In a submarine equipped with a sonar, the time delay between the generation of a probe wave and repetition and reception of its echo after reflection from a enemy submarine is found to be 77 seconds. What is the distance of the enemy submarine? Speed of sound in water is equal to 1450 meter per second. So we can write 2.30. Let the distance between the ship and the enemy submarine be s. Speed of sound in water is equal to 1450 meter per second. Time lag between transmission and reception of sonar waves. Second, in this time lag, sound waves travel a distance which is twice the distance between the ship and the submarine, which is equal to 2s. Time taken for the sound to reach time taken for the sound to reach the submarine is equal to half into 77, that is 38.5 seconds. Therefore, distance between the ship and the submarine S is equal to 145 multiplied by 38.5, which is equal to 55.8 kilometer. Now let us check the next sum. 2.31. The farthest object of our universe discovered by modern astronomers are so distant that the light emitted by them takes billions of years to reach the earth. These objects known as quas- quasars, this object known as quasars have many puzzling features. which have not yet been satisfactorily explained. What is the distance in kilometer of a quasar from which light takes 3 billion years to reach us? So 2.31 time taken by quasar light to reach Earth is equal to 3 billion years. Now, which is equal to 3 10 to the power 9 years, which is equal to 3 multiplied by 10 to the power 9 multiplied by 365 multiplied by 24 multiplied by 60 multiplied by 60. So this overall calculation will be, we'll do the calculation at last. So this many seconds. Now speed of the light is equal to 3 into 10 to the power 8 meter per second. So distance between the Earth and quasars is equal to 3 into 10 to the power 8 multiplied by 3 into 10 to the power 9, 365 multiplied by 24 multiplied by 60 multiplied by 60, which is equal to 283,824 into 10 to the power 20 meter, which is equal to 2.8 multiplied by 10 to the power 22 kilometer. Now let us see the next sum, that is 2.32. 2.32. Now let us see the sum. It is well known fact that during the total solar eclipse, the disk of the moon almost completely covers the disk of the sun. From this fact and from the information you can gather, from example 2.3 and 2.4, a determination 2.4, determine the approximate diameter of the moon. Okay, so question number 2.32. So what we'll write, position of the sun, moon and earth during the lunar eclipse. Position of sun, moon and earth during lunar eclipse. Lunar eclipse. So we can draw this one. This is sun. This is earth. So we can write here the diameter, this point as V, so this point is P, this is Q, and we can draw a line here. And so here we can draw the moon. So here also the diameter is R and S. So this is moon, this is sun, this is earth. And anything else here? They meet here in the earth at a point T. Now so this point is T. Now let us understand the problem. So we can write distance of moon distance of the moon from the earth is equal to 3.84 10 to the power 8 meter. Distance of the sun from the earth from Earth is equal to 1.496 into 10 to the power 11 meter. Now distance of the Sun is equal to 1.39 multiplied by 10 to the power 9 meter. It can be observed in triangle TRS and triangle TPQ TPQ triangle this and triangle this are similar, hence we can write, therefore we can write PQ upon RS is equal to VT upon UT. Now if we put the value, we'll get 1.39 into 3.84 upon RS is equal to 1.496 10 to the power 11 upon this much. So into 10 to the power 8. Therefore, RS is equal to 1.39 into 3.84 upon 1496, which is equal to 3.57 into 10 to the power 3.75 into 10 to the power 6 meter. Hence the diameter. Therefore, the diameter is the diameter of the moon is equal to 3.57 into 10 to the power 6 meter. Now let us see the next question. Next question is, a great physicist of the century, P.A.M. Dirac, loves playing the numerical values of a fundamental constant of nature. This led him to an interesting observation. Derek found that from the basic constant of atomic physics, mass of the electron, mass of the proton, and the gravitational constant g, Derek found that from the basic constant of atomic physics, c, e, mass of the electron, mass of the proton, and gravitational constant g, he could arrive at a number with the dimension of time. Therefore, it was very large number in its magnitude and being close to the present estimation on the age of the universe, that is approximately 15 billion. Now, it is very large number, approximately 15 billion years. From the table of the fundamental constant in this book, try yourself to can construct the number, so or any other interesting number you can think of. If it's coincidence that the age of the universe was significant, what would this imply for the consistency of the fundamental constants? So here we'll start with so we can write here 2.33. One relation consists of some fundamental constants that give the age that give the age of the universe. I is equal to e square upon e square upon 4 pi epsilon naught square multiply by 1 by mp mc so mp mc uh, me, it will be me and me square C to the power 3g. If we put the values, we can get now. So this is, again we have to check the question, what is it is asking for. Okay, now we got it. Now they're asking for the time, so t is equal to 1.6 10 to the power minus 19 4 9 to 10 to the power 9 square upon 9.9 into 10 to the power minus 11 1.67 into 10 to the minus 27 3 into 10 to the power 8 10 to the power 8 square, sorry, this is cube, and 6.6667 into 10 to the power 11. So putting all the values, known values and unknown values, so we get so we can write in this way. So the answer will be 6 into 10 to the power 18 years, which is equal to 6 billion years. So this is the end of class 11th NCERT Physics Chapter 2. So NCERT Solution.